So in this case, we'll be first using a slightly different SQL engine. So remember, in let me start sharing my screen. So yeah, remember in the previous case we were using SQLite, right? Here we are going to be using PostgreSQL. So PostgreSQL has several more very useful and advanced aggregating functions. That's why we will be using PostgreSQL instead of SQLite. So this case we are let's imagine we are data scientists working at a fast-growing startup, and we have launched a product a year ago, and then we have been trying to track the users' satisfaction by asking them to give us a rating. We call it the Net Promoter Score, or NPS. So we wanted to monitor how the NPS changed within the past year. We want to know, has it been going up or more or less the same, or the worst going down? That means the user are getting more and more dissatisfied with our product. So yep. So in this case, we will be working with a simpler database, which is visualized here. But we'll be going to be doing more complicated queries and calculations. So before we look into the tables of the database, so let's look at what we ask our users to rate. Is based on it's actually very similar to a lot of the surveys that you fill out, even for the DSY program. So it's typically the users are asked to give a number or a rating, how likely that you would recommend this product that our company built to a friend or colleague, with 0 being not at all likely, and then 10 being very likely. So here we also categorize the users into 3 groups, depends on the numbers of ratings that they leave. So whoever leave a rating of 0 to 6, we treat it as detractors. That means these users might be causing us to lose usage or lose customers, okay, which is what we don't want to see. A number of 7 to 8, we are going to regard them as passive. So typically for users who rate the product with a number of 7 to 8, it probably means they think the product is okay. Whether I'm going to recommend it to the people around me, maybe not. And then the last group, users who are rating as 9 or 10, we regard them as promoters. That means we believe them that these users truly like our products, and they really wanted to let more people know about our product, which would be good for us. And then so the final NPS score of a given period, we define it as the percentage of total users who are promoters, so the number of the fraction of promoters among the users minus the percentage or the fraction of detractors. So since these are all percentage, that means an NPS score can range from -100 to 100. So if you think of all the users gave us a rating of 0 to 6, which means they're all detractors, and which means we have 0% of promoters, which would be really bad. But just hypothetically speaking, we would have an NPS of 0 minus 100, which would give us minus 100. And then also the other case, if we all have promoters, no detractors, the percentages would be 100 minus 0, and then the NPS would be 100, which would be great. And then the NPS, if we have 50-50, like 50% promoters, 50% detractors, then we would get an NPS score of 0. So the 0 means we're probably not doing super well as well, because we of course we want to minimize the number of detractors and try to convert them from detractors to promoters, right? So that's the business context that we should keep in mind. So like I said, in this case, we'll be using Postgres SQL. So what you need to do is first go to your workspace and then open a new terminal. And then in the new terminal, you would need to run this script. So / setup tsql.sh. And then if you're running it successfully, then you would see similar output here. The UTC, you would see the terminal creating all the folders, databases, tables, okay. Configuring the settings, okay. Initializing the database, okay. And you would see server started at the end. That's what you should expect to see. If you're running the PSQL setup successfully. Yep. So the command that you need to run on the new terminal is / setup psql.sh. And then after that, you can come back to the first cell here. And then you would have, and then you should have it running. It would take a while. So just let the server do the work for you. So why am I getting an error? Because there's the database is already set up. So that's why. If you don't have any error, then you should be fine, and you should be able to go straight to the cells below and then start writing queries. if you are having problem, so what you should do is go back to terminal, run this different script called shutdown pstl.sh. And then it would shut down the Postgres SQL database on your server, and then you can rerun the cell. You can rerun the cell here to ask it to start up your SQL server again. So don't. So I'm gonna talk about the ERD while a lot of you might be starting up the SQL server. So here we have two tables. One is about the customer. Of course, we have the primary key, which should be unique, is the customer ID, and then when it's created, and then two booleans to indicate whether that customer is a premier customer or that customer is just a spam customer. So it could be neither. So a customer can just be a normal customer, which means they're not premier nor spam. So they can both be 0. And then the next, you will have you also have the score table. Of course, we have the foreign key here is the customer ID that is used to link up the ID in the customer table. That is for us to have a reference of all the scores, which scores were left by which customer. Scores, the date time when the survey was done, when the score was recorded, and also what score did they give us. Okay, so so let's see. So keep in mind that since the business setting is a startup, we might have some features that are not working super well, or there might be some bugs in our product. So that might be resulting in a lower and lower score in the survey. That's okay, as long as we are trying to improve the score, the customer satisfaction. The more we care about should be the trend. So let's dive in to our first exercise is to ask us to write 2 queries to count how many customers and how many survey responses that were in our database. So this is relatively simple. We just count all the rows in our customer table, and okay, why server closed connection unexpectedly? Interesting. Let me try this as well. All right. Why did it stop working just right now? Let me. Oscar or Monica, is there some disconnection happened? Looks like.
Hi, Sam. Yeah, just a second, please.
No worries. Looks like I think it's just too many of us are loading the data at the same time, and we are reaching the limit. Okay.
Yes, Sammy, just set up the server again, and it's going to be working. Also, I believe that script is also executed directly from the notebook.
From the case, yeah.
Yeah, I believe the first cell is creating the database, is installing the database hidden or not. Yeah. That
Yeah,
run database,
yeah.
then for example, you can delete the database and run that cell, and it's going to run what we are doing from terminal is going to be done there. For example, let's show the follows. Delete the database from the terminal. That way it's clear for everyone. Please delete the from terminal. Just delete the database. Yes, we are going to delete the database completely, and we run the first cell. And then go to the case, and we are going to run the first cell. That is going to execute that database underline setup that py script. That script is going to install the database, but is also going to load a lot of data inside of the database. Then the problem was because Sami was showing how to delete the database. We installed the database, but we didn't load the data. Then we need to execute this cell. That way, it's not only going to install, it's also going to load the data. Then let's wait some minutes. Sami, if you want, we can take a little break. Oh, it's done. It's done. For you from the workspace, is going to take longer because the workspace is less powerful than the instructor server.
Yep. And we are back. Thank you, Oscar. Okay, so we see that we from the customer table, we have 188,000 customers, and then yeah, which is not bad for a product running for a year only. And then we can check how many score entries were there, and we have 1.5 million survey responses. So that's actually also very good as well. That means we have very responsive customers. On average, there were like almost 8 responses per user. So let's look at it more closely. So here for the exercise 2, we were asked to write an inner join that outputs a table showing 10 customers with the highest number of responses and how many responses were there, right? So again, let's write down some of our thought processes. Of course, SQL as a start. So let's see, we would want customer ID, right? Customer ID. Customer dot ID, and then the highest number of responses. So the number of responses that we need. So we'll probably need count everything from score. And then we would need to do a join. So why don't we apply what we just learned and do an implicit join where customer dot ID equals score dot customer ID, right? And then don't forget we need to also do a group by, right? So this one I'm gonna leave it out for you to get that. And then of course we also need to order by, and then like I said, it's always good practice to put a limit 10. And then one crucial differences between Postgres SQL and SQLite is you should always remember to put a semicolon here at the end. So in the previous case, all the queries that we wrote and run didn't need to, but for this case, all the queries and SQL commands that we run on the Jupyter Notebook needs to have the semicolon. Otherwise, it would give us an error. I think that's the same syntax for MySQL as well. So for if you're using MySQL server, which is also pretty common, you also need to put semicolon in all of the commands that you run. Okay, so let's work on it for another 5 minutes. Play some music and let's come back at 11:40. Okay, let's come back. So below is one of the answers was the possible way to do it. Here it's using inner join on customer ID equal customer.id. So here, which is so it's referencing customer ID with the score.customer ID. So if we run it, you would see the top 3 customer IDs were number 31, 928, and 4271, with the counts, which of them, with each of them gave us 38 responses, and then we also have a few who gave us 37 responses, and then a bunch more gave us 36 responses. So that's pretty good. But then the next step, what we want to do is we would want to do a count of counts. So just to see what scores do most customers leave us. So what we want to count here is exactly how many customers left a particular integer between 0 and 10 for us here in their number of responses. So what we needed to do is we needed to utilize the nested queries or subqueries, which we just learned in the previous case. So here we have the outer query and the inner query, or what we call the subquery. So what SQL would do is it would always execute the inner queries first, and then execute the outer query. So, for example, here this example is selecting all the premier customers in the subquery, and then now we want to select everything from the score table with a condition that we are requiring all the customers to be our premier customers. Okay, so it will first execute. It will produce like a virtual table. You can imagine it as a virtual table with all the premier customers selected as a subset of the customer table, and then select all the scores, and it will match all the customer IDs with the virtual premier customer table, and then output what we want for the score. Okay, so here is one example asking us to write a query to show how many customers so how many customers left us what sort of integer values or score for us. And then we were asked to sort the table in descending order. So as you can see, here is the inner query. So in this inner query, we are selecting the customer ID, okay, and then how many responses that they left from the score table. And then, of course, we reference the linkage of the two tables by asking the customer ID equals to the score dot customer underscore ID equals score dot customer ID group by the customer ID, and then do the typical group by and order by that we want. So, okay. Let's see. The server is down again. Okay, let's see. Let's go to the terminal and shut it down. And then here we restart it. Let's give it a minute, it would run. Let's take the time to all stand up, stretch your legs, and drink some water, get hydrated as well. Okay, that's still not working. Okay, let's try it again. So meanwhile, setting up, let me start by explaining this as well. So here we have this inner query. So it's also typically a good practice to write the inner queries with a tab indentation. So so it's easier for other people who read your code, understand this, oh, okay, you're doing a nested query or subquery here with the inner query here. This A is just an alias, so you can type in as A as well. So yeah, exactly. A is the inner query. So so let's see if we are back. Still running. Okay, that's done. Great. Nice. So okay, so we see that a lot of 5, 6, and 7, and then here here we know we've chosen the alias A here. You can pay attention that we'll probably be reusing this again in the subsequent queries. So that's why we put an alias here, just in case in the later queries when we have more nested queries, or if we needed to reference the column names here, for example, the CNT, we can reference this as a.cnt. So that's the purpose. So so let's see, we can so from the queries, we would see a lot of the customers actually leave a relatively small amount of feedback for us. So we can definitely tell that like 38 is an outlier. So most of it, as we see, most of the customers only give us this a relatively small number of feedback, smaller than 10. So the next exercise that we wanted to do is we want to look at the average scores per week. So it's very important for us to keep track of how the score is changing along the time. So in Postgres SQL, there is a special function called toChar or toCharacter. It's a function that reads in the date and break it down and sort it into a specific week number. So if we take the score.created@, so let's go back up. Here we have the score created at column, which recorded the time when the customer did the survey. Postgres SQL, that toChar function can read in that date and then group it into the number of weeks. So so here, this is the syntax toChar score created at the field that we want. And this is the specific format. So this is the year and the week. And then we calculate the average of the score, and then group by the week, and then order by the week. So we actually don't have to put limit 100, since we know a year only has 52 weeks. We can just do say 60, and then if you run it, and it crashed again. That's okay. I'll shut it down again and restart it.
Sami, please remove it or do not install from terminal the database. Please only.
Okay. Just run the first cell.
See, yeah. Only delete the database, and you run the first cell, because the first cell is I know it's confusing because it's a hidden script behind the notebook. I do not recommend this. Sometimes when you try to make it simpler, you make it complex. But that way it's going to install the database and load the data, and only that cell is doing that.
Only that cell, yep. So Oscar, I should just shut down and then run this cell again.
I believe no. Let's wait until, okay, go to the terminal.
Yep.
Okay, type Control-C to stop that process.
Yeah.
and run the delete script, the shutdown, that one. Okay, then that way we deleted Postgres, we deleted all our data. Then let's go to the notebook and run that cell. That cell is going to install Postgres and is going to load the data, but everything is hidden inside that database underscore setup.py script. Then if someone wants to understand what are we doing, we are summarizing all the installation process and the data loading on that script. That's why that cell is taking a lot of time. But okay, set up a return 0. Why is crashing? Why is crashing? Okay, that database system is okay. Type Control C. Okay, please run the shutdown.
Again, yeah.
Okay. Okay, I believe it's deleted. Please type kernel restart in the notebook. Run. Let's do a kernel restart. Restart and clear output. And let's see if we can run
it again.
I believe there are some libraries in the top that we need to run. Okay, please stay on that cell, Sammy, to see if it crash or we continue or we can continue, because right now we don't have database. Without data, you can do nothing. Okay, what's going on? Okay. Operation error setup. Okay, create premarital. Please scroll all the way down, Usually the okay. Okay, we don't. I believe we don't have at the top of the notebook. Is there anything else? Any other cell that we forgot? No, there is not any other script. What's wrong with that? Any clue, TAs in the TA channel? Okay, let me. Okay. Okay, Sammy, let's do this. Please delete the database again. Okay. Let's see if, okay. Okay, then start it. Oh, no. Then let's start run that cell again.
Let me restart the kernel just to be safe.
Yeah. And also, please, we need to shut down. I am going to enter to the instructor server, and also I am going to close any other notebook that is open.
Yeah.
To see if maybe there are more terminals with garbage. Maybe go to running. That's also a good lesson on the Jupyter notebook. To see, okay, let's wait until that cell finish, and we see if we can continue. Okay, now it went through. Yeah, then please run the first select. Only the first select, please.
Only the
first
select.
Only.
Yeah.
Okay. Then we can continue.
Great, thank you, Oscar. So Okay, nice. So we're finally back online. And if we run this query to get the average score per week, the output that we would see is from the first week of 2018, the average score was 5. And then looks like after 2 months, we have made some improvements. It's now we're receiving mostly 6 and 7s, and then almost 8, and then more 8 towards the first half of the year, and then okay, until here we had a slight drop back to 7. So probably a bug happened in our product in this month, causing the ratings to drop a little bit. And then we got it fixed, and then it went back up to 8, and then moving along to almost 8.5. So cool. So looks like we, after we launched the product, we made some improvements, and we are getting a lot better satisfaction from the users. So here, let's work on exercise 3. It's asking us to write a nested query to compute the average score across all customers per week, rounding off to 2 decimal places. Of course, using the round function, which we already have covered here. So let's copy this, and then and what we needed to add is do the average for all customers. So in the previous query, we are computing the average for all customers. And then let's see, and then I think right now we are asked to compute the individual customer average rating per week. So let's see, we will need, let's finish our thought process, and then we'll go into music time. So let's see, we'll have to do a cool. I see someone already making a plot. The difference between IYYY and YYYY, I'll cover that at the end. So don't worry about it too much for now. So right now here, we also needed to do a join. See. Let's remember example 1. That's exactly something that we can use as inspiration. So then the next step, of course, would be we need to join the customer ID and select. Then we wouldn't be selecting this. We would be selecting something like this, right? Okay, so and then we do the group by the week, and then order by the week. That should be hopefully be enough to get you all started on thinking about and working on the query. So let's work on this for maybe another 5 minutes, and we will come back at 11:16. Okay, let's come back. So this is quite a lot more difficult than the previous queries that we have been doing. So it's definitely okay that if you couldn't figure it out. But then I also see some very smart fellows who got it done. So let's see. So here we are selecting the week and the average score from this table. So this is the alias. Use it as A. So this is the average score from for the per customer ID. And right, look, yep, and we were able to get the results that we wanted. We probably don't need 100 as well. We can just put a 60. So cool. So the next exercise that would be useful for us to look at is we'll be classifying our customers into the three classes that we mentioned before: the detractor, passive, and promoter. And then from using that, we will calculate the NPS per week. So here we will be we'll be using two nested queries. So it's getting more and more complicated. But let's look at it. Let's break it down and look at it and see how do we make sense of it. So let's look at the innermost query first. So again, we are here to select the score per week, of course, and then the customer ID, group by the week, and the customer ID. So we are basically doing the exercise above, repeating the exercise above, selecting the average score rated by our users per week. So then we have this virtual table, and now that we want to have we want to classify the customers. So here we are adding another column called NPS class, where we assign a case. So the case, this is the syntax of how we are classifying our customers. So from the so we are reading from this virtual table saying, oh, if we look at this average week score, if it's larger than 8, then we assign that customer as a promoter. If it's larger than 6, then it's a passive. And else would be a detractor. So here you can also require that the average week score smaller than or equal to 8. Then passive, and then everything else detractor. So this is so this is how we first create a virtual table of the customer ID and their average weekly score, and then try to classify them. And then after we assign the classification to that virtual table, then here we are asking SQL to select everything from this table. Yep. So so we have these a whole bunch of detractor. We would expect to see more detractors than promoters in the first week of 2018, because we remember the average score of 2018 the first week was only 5.12. So it's very likely that most of the customers gave us a rating lower than 6. So a lot of them would be classified as detractor, while a smaller number would be classified as promoter. So, and then also we noted these two tables with aliases named A and B, which will be reused here again. So since we didn't really do this, the format that we're asking it to display isn't very helpful. First, we're only displaying limit 10, so only 10 rows, which would all be reflecting the scores for the first week of 2018. So we definitely need to do more group by. So so another more useful step that would get us closer is we try to count the different classes. So if we run, we still have almost a million rows. So that means throughout all 52 weeks in 2018, there are still a million rows of average score that we received. So so now then we needed to sum the number of promoter, detractor, and passive within that particular week in order to get us to what we want to see. So here is select the week, and then this is where we do the sum. So case when NPS class is a promoter, then we count it in. Else, if it's not a promoter, then we don't count it. And then we assign this sum number as promoter, similar for passive and detractor. So in this particular week, if it's a passive, then we count it. If it's not, then we don't do anything. And then same for the detractor. And then we are going to apply the same nested queries here. So we should probably add this as well. Average week score small equal to 8. And let's try to run it. you would see it's taking a lot longer to to run, since it's running a lot more things now. First, we have the 2 nested queries, and then so we have the virtual table A created, and then we assign each customer ID in that virtual table A as a promoter, passive, or detractor, as a copy or an extra column from the virtual table A, which we stored as the virtual table B. And then from the virtual table B, we sum the number of promoter, and then sum the number of passive, and then sum the number of detractors. Okay. And then here we also included counting everything as a total from the virtual table B, and then group by week, order by week as usual. And we finally get the number of promoter, the number of passive, and the number of detractors per week. And the total would be the sum of these 3 numbers. You would see 65 plus 2 plus 63 is 130. And there we go. So we have these numbers of promoter and detractor per week. Then the natural next step you can think of to do would be we can actually start calculating the NPS score per week, as we say. So here, so we can first have this formula in our mind that let's go down. Yep, exactly. So NPS is the fraction of promoters minus fraction of detractors, and then multiplied by 100. So what would happen basically is, so let's take week 3 as an example. So we have fraction of promoter, which is about half of them, and then minus the fraction of detractors, which is also approximately the same. So we would expect the NPS score that we should get for the 3rd week in 2018 should be about 0. Okay, so let's have this quick number concept. Let's keep that quick number concept in mind before we again dive deep into the syntax in terms of how to figure out the SQL cluster and calculate the NPS. Okay, so here we have this same query table from what we did above. Here it's the same, and then we just assign it an alias name, a nickname for it to be C, right? And then here is then we are trying to do some calculations, right, for the NPS. So here we define the NPS as number of promoter. So we first have to do a cast to a decimal because this is all these the number when we were doing the sum, they were added together as an integer. So in order to do the fraction as in the division, we have to cast it as decimal. So that's why this is here. So we first cast it as decimal, the number of promoter divided by the number of total, and then minus the fraction of detractor, and then multiplied by 100. And then we round it back to 0 decimal points as our NPS. Okay, so let's try running it. Nice. So we are seeing this, the NPS column being calculated, right? So just like we said, we wanted to keep in mind to check if our query did the right thing for us is to have some quick example numbers done in our head. So in the third week, we said since the promoter and the detractor, the numbers were more or less the same, the NPS value we should expect to be somewhere around 0, and we got 1 here, which is right where we expect it would be. And then we can see that from as time goes on, we really see the NPS going higher and higher, from -20 on the first week, going to 0, and then going to pretty close to 50s for the first half of the year. And then we started entering 60s for NPS in the summer. And then, like we said, we remember there was a drop. There was probably a bug in, say, September, October, given the number of weeks. So, and then the engineering team fixed the bug, and then the satisfaction went back up. So we're also seeing the NPS went back up to the 50s and the 60s. So yep, we can now see the NPS rounded for any given week. So cool. Any questions so far? Okay, no. So then we are now gonna introduce a few more function or keywords in Postgres SQL, so which are namely the ceiling and the floor. So this is, for example, for the ceiling and the floor, it's basically doing the same thing as rounding, but then it's just for ceiling, it's always rounding up. So for example, if you have a number 1.2 and you ask SQL to round it to the closest integer for you, it will give you 1. But if you're asking ceiling of 1.2, then the SQL will give you 2. And then similarly for the floor, if you have a value of say 1.8, if you apply the floor, it would give you 1, while rounding it would give you 2. So that these are differences. So here this is an example of how we apply this ceiling or flooring function to calculate how the score changed along every month. So instead of weeks, we wanted to see how this score was changing along the months. So this is the extra step that we needed to do, is to cast a substring as decimal and then divide it by month. So what this substring here is doing is it first read in the week, and then you want to include you only wanted to include the week number. So here you have you remember here 2018-52. So there are 7 characters here. And then if we do substring week and then 6 and then 8, you will get back the number 52. So that's how we extract the number of weeks from the column. And then after that, of course, it would be extracted as a string. So we cannot do any calculations with that. So then we do the same trick as we did before, is casting it as a decimal. So we now would have changed the number of weeks to from string to decimal, and then multiply it by 12 divided by 52. So what it does here is basically track which week of that year is. So, and then divided by 52 and then multiplied by 12 to get the month. And then since we have the months, but then of course as a decimal, we have to do a ceiling so as to round it up. So why we not rounding it down, not using the floor? Because so given the first few weeks here, if we are extracting 1, 2, 3, 4, and then get the number of months, it would be 0 point something, right? So, but then since our monthly count, we start with January, start with month 1, so that's why we use ceiling here to assign the month number to the number of weeks. And then the rest of these are really the same. So same from the previous query that we did. And let's try running it and see. Okay, cool. So we successfully calculated the month number as a new column here, just as months. So what we did was just copying the exact same table, but then we wanted to compute an extra column of months assigned to the week. So here we would see the week and its corresponding month. And like we said, the score did drop a little bit in the second half of September. And then the engineering team fixed it, and then the score slowly went back up in October. And then we ended up high at the end of the year. So that's great. So let's see. So the team is now interested in the months that had mean of the month moving by more than 1.5 standard deviation. So the team now want to locate possibly some serious events that happened causing the score to fluctuate by more than 1.5 standard deviations, as we typically consider that to be a significant fluctuation. So the rest of the case, we would be spending the time trying to locate these months that we know were fluctuating. So for example, we know the month September, we would expect seeing September as a result, right? Since we saw a pretty significant drop from say 60 to 38, right? And also we should probably expect to see a pretty significant increase from January to February, since it increased from -20 to 0 and then up to 30. So these would be some of the more significant changes of the NPS that we see. So here, this example is asking us to write 2 SQL queries that will output the mean NPS of the month and the standard deviation. So we can copy exactly the same of what we have in this table, and then compute the month, the mean and the standard deviation grouping by per month, right? So that is what we would expect to see. So this part, don't freak out. I know it's getting longer and longer, getting scary and scarier, but the part that I highlighted is exactly what we did coming from here. Okay, so the only new thing that we are doing here is we are doing average NPS and then the standard deviation of that NPS per month. So how this is done is, of course, like I mentioned, we would have to do a group by month here, right? Since we you see a bunch of stats here is because we, from the nested query table, so this is like, you can see this as a virtual table called stats, right? And then from this virtual table, we're querying the month, and then the NPS, do the average, and then again querying the NPS, but do the standard deviation, and then ask it for the output. So so let's try running it. Right. Okay. So we have the NPS and the standard deviation. Of course, it's pretty nasty to look at. So let's do the round. Maybe even just one. And let's try running it again. Great. So now that we have all 12 months here and the average NPS, we see the same trend again and again. It was pretty bad in January, but then it improved very quickly. By April, we are consistently above 50, and by June, we're consistently above 60. And then the standard deviation is also getting smaller. So that means we're getting more and more consistent ratings from our users, which is good. So so let's see. Exactly. So I know a lot of you, if you're more familiar with pandas, you can do this like a lot quicker. This is meant to be served as an SQL exercise, but then if you're dealing with a very big database that have a much bigger number of tables, if you're having 3, 4, 5 tables, and you need to do a lot of joins to get the quantity that you want, then just like just like some of you said, a good SQL query can save you a lot of work in pandas. So then just also let me see. Let's see. So we can also go into the month of September a little bit more, as we saw the standard deviation is quite big. That means in the month of September, not only the NPS average dropped quite significantly, but we're also getting a more polar view about our product. So it can be the case that some users might be experiencing the bug, and that caused a lot of trouble for them, and therefore they gave us a very low rating. But the bug may not be affecting all of the users, so some users might still give us a pretty high rating. That's why the standard deviation was sort of bigger. And then, but after we fixed it, we saw the average NPS went back up, and then also the standard deviation went back down. So if you think about the average and the standard deviation, the relative values, it's actually very consistent. Because if you think about the standard deviation is only 1.7 out of 61 average NPS. That means a very high percentage of our users were getting the same good experience and therefore giving us a pretty good rating. So that's how we should always keep a sense of when we are looking at numbers and quantities. When as I was in my research days, when we talk about average, we always report the standard deviation along with the average. So just to give people a sense of how consistent your data set is, that will give you a lot of ideas of how consistent your measurement is. So it's always important to not to only look at the mean, but also look at the standard deviation as well. So so here we have a diagram that basically summarizes what we did. It's a lot, I understand. And the corresponding output. So let's review it once again quickly. So first we selected the customer ID and the score that they gave every week. So here the output we have per week and the customer ID and the score. And then we classified them, the users, into whether they are passive, promoter, or detractor. And then after that, we calculated the sum of the total number of promoter, passive, and detractors per week. And then we grouped by all the weekly ratings into per month. So we switched the time basis from per week to per month. And then we calculated the average of the NPS and the standard deviation as well of the NPS. So so this is again so this is again the same query, but then here we are only selecting distinct. What it means is it removes the duplicates from our results. So let's try running it. Okay. And now we get the NPS again per month with the duplicates removed. So for example, what it does here is there is a possibility that the same user might have given like the same rating, and that would mean that our calculation of NPS double counted some of the entries, and now here we're only using the distinct entries to get rid of duplicate. So this is pretty much exactly the same. If you're more familiar with pandas, it would be doing the same, performing the same function as drop duplicates. So this is also about. So let's run this query as well. Comparing, so here we are doing some more calculations right now. So we wanted to do the average NPS of the month and compare to the first NPS of the month and divided by the standard deviation. So what we are trying to do here is since let's go back up to the weekly scores that we have, right? So so let's look at January, for example, the month. The first week we got a pretty bad NPS, but then after that the NPS improved quite a bit, right? So you would see the NPS of the second, third, and fourth week were significantly higher than the first week. It's almost like the first week was an outlier, and we sort of see the same trend for February as well. For February, we see a pretty low beginning NPS, like 15, and then for the second, third, and fourth week of February, we see a much higher and a much more consistent NPS. So 30, 30, 28 compared to 15. So so that's the case for January and February, but then for April, May, June, July, so these become quite a bit more consistent. And then the other example that would be interesting to us is the month of September. For the first week, it seems like we were still receiving a pretty good NPS, but then the bug probably happened, and we see the rest of the weeks we got a much lower NPS than the first 2 weeks. So, and then it slowly rose back up. So that's the reason why we would want to calculate the standard deviation of the monthly NPS and see which of these are outliers for us. So what we see here, so of course, why the NPS average SPD were all not rounded. Well, let's see. Select. Let's try this. see if that helps. Yep, it does. Okay, that's good. And then we should round these as well. Okay, so now we see the monthly NPS, standard deviation. And the first week of the NPS, right? So here we can see from the results, these few months, 4, 9, 7, and 5. These were the only ones with a negative num-STD, which means in these months, the average NPS was lower than the first week. So in these particular months, April, May, July, and September, we saw it, the NPS rating started up higher and then it went down along the months, especially September. Like we said, we remember saying, we were saying for September, it started off pretty high at 60 and it dropped to 38. So that's sort of the most significant drop here. And then however, for April and May, we know that might not be the best idea to claim April by looking at this method, to claim that April or May were a bad month, because we remember April and May, we have been seeing that are the scores that we get for NPS were quite consistent. So even if the num-ST were negative, it's still a very small decrease. And there's always, by doing this kind of measurement, like especially when we are averaging a large quantity between these ratings 0 to 10, there are always some statistical fluctuation. So if we look at the month of April and May here, these might just these scores, like going from say 53 to 51 and then back up to 52 and then back up to 54, like these are very likely to be statistical fluctuation. So by doing some measurement, we always expect some fluctuations in the distribution. So that's why we use the standard deviation, or even maybe 1.5 of the standard deviation, to quantify whether that is a statistically significant change or not. So for example, since this month of January, since we have a standard deviation of 10 already, even though we see a num-STD of 1.45, it's still relatively small compared to the standard, to the range of fluctuations in January. That's why we probably don't have to how should I put it? We shouldn't care too much about the fluctuations if the standard deviation is fake. But then in this case, if it's the other way around, like, let's see if we can find a month. Let's see. If the standard deviation is small, but then the NumSB was big, then it probably means there's a big change in that particular month. So these are just some sense of numbers that I believe we all should develop as a data scientist, is to have a sense of what the average means. It always it wouldn't mean much if we don't quote the average without the standard deviation, right? So we should always keep in mind that to pay attention to the standard deviation, and then compare the fluctuations. How big are they relative to the standard deviations? From that, then we can tell whether that fluctuation is significant or not, and we should pay attention to that, whether that we can count those as an outlier or not, or if the fluctuations are within the standard deviation, then it most likely means that we are just seeing some statistical fluctuations that we cannot completely rule that out as normal fluctuations, and we cannot consider those events as significant statistical outlier. So I know we're running a little bit late, and then yep, we can order by month here. Oops. Let's see. Did I miss something? No. Let me run that again. So we're almost at the end of the case. So let's see. Inner join. Let's see, group by month, and then see if this works. Yeah, there we go. Cool. So the last exercise, this is really pretty advanced. So here is asking us to use the slope to calculate the weekly slope of the NPS, and return the slopes that are positive. So so what it does here is here calculate the slope. So it takes in the monthly NPS. So let's go back up. So it calculates if you by a monthly basis, it calculates. So say for the month of May, 54, 53, 52, we would see the slope of this month of the average NPS is slightly negative. So then let's see. Let's run that. And yep, we saw that the months of May, July, and September, we saw the NPS were sort of decreasing along the weeks. So that might also be some useful information for the analysis team, as we see that why we wouldn't care April and May as much as September, because the even though the slope was negative, these were like fairly flat decrease slope. But then while for September, the slope is very steep. So we know from the slope that it is very significant, and we can just display, let's say, display all the slope of the month, and then we'll get a better sense of what it means. So January, February, March, we know that the NPS were increasing. So we got a positive slope, and then 4, 5, April, May, July, June, July, they were like sort of consistent. And then we had a big dip in September. That's a big negative number for the slope. And then we fixed the bug, and then the NPS rating were sort of back to slowly improving, back to where we were. Yeah, so that's the end of the case. Sorry for running a little bit late because of all the various issues happened. But then here's a summary and the cheat sheet on nested queries. We also did a pretty useful function in Postgres SQL, is the toChar function. So here you can have the format of the year, whether preserving the ISO week numbering standard or not. And then you can also not only year, but you can also further specify the day of the month, hour of the day, minute, and second for daytime columns. Yep. And then yeah, I understand these were like getting very long and gigantic queries, but if it's definitely normal if you're feeling lost. If I was seeing this for the first time, I would have the same feeling as well. So just play around with the code. I believe most of these answers should be posted to the Slack polls and answers channel, and definitely reach out to me or to your TA as well if you have any other questions. I will also put my contact info there on the live chat. So yeah, I believe all of us are hungry to go get lunch, so I will stop here.
Okay, thank you so much, Sammy, for the lecture. Great lesson. And don't worry, guys, it is normal if you're struggling. So don't worry, just be patient and, just practice a lot. Okay, so before you go, I want to thank again, Sammy, for the lecture. We are very sure our fellows will find this knowledge very useful in the near future, especially because we are going to launch our extended case at the end of the day. And guess what? It's all about SQL. So thank you again, Sammy. Y bueno, chicos,
Thank you.
recuerden que SQL es uno de los lenguajes de programación más utilizados para el manejo de bases de datos relacionales, ¿cierto? Esto nos permite extraer, manipular de manera fácil, rápida, eficiente la información y es altamente
Muchas
utilizado.
gracias.
Oh, you're learning Spanish. Awesome.
Sí.
Okay. Entonces, chicos, recuerden que este lenguaje es muy importante en el mundo laboral, por lo que los invitamos a aprender bastante y ponerlo en práctica, especialmente con nuestro extended case. Ahora sí, vamos a nuestra hora de almuerzo. Estaremos de vuelta a la 1:30 para los team meetings. Y recuerden que en las horas de la tarde, cada TA pair hará la revisión del extended case de Basic EDA en Python. No se lo pierdan. See you soon. Thank you again, Sammy. Have a great
Adiós,
day.
amigos y amigas. Adiós.
Adios, Sammy. Bye, guys. See you soon.